Hi everyone, this is the last lecture in Unit 4. Today we're doing Lesson 4.4, Rates of Change in Polynomial Functions. To determine the rate of change, it's simply to calculate the slope of any given function. The slope is estimated in instantaneous rate of change at a specific time. Recall that to calculate the average rate of change, we need 2 points on the graph. One being x2, the other one being x1. Then we have to find out the corresponding y value for these x's, and that will be f of x2 and f of x1. We then have a general formula that says f of x2 minus f of x1 divided by x2 minus x1 equals to the average rate of change. Now let's take a look at example 1 from your learning resources. It asks us to determine the average rate of change from x equals to 2 to x equals to 5 on the function f of x equals to, in bracket, x minus 2, bracket close, squared minus 1. For this first step, since the x values are given, you sub those values to find the corresponding y value. That would be the f of x. So when x is equal to 2, f of x equals to negative 1. When x is equal to 5, f of x equals to 8. Step 2 is the equation to find the average rate of change is y2 minus y1 divided by x2 minus x1, and sub in the x and y values that we just found out in the previous slide. So that would be negative 1 minus 8 divided by negative 3, that would be 3. Therefore, the average rate of change is 3. If a graph was given and asked to find the average rate of change, graphically find the x or y value corresponding to whichever number is given. As long as the 2 points on the graph is found, the average rate of change can be found by subbing the numbers into average rate of change equation that we just did in the previous question. Example 3 asks us to estimate the instantaneous rate of change in f of x at point 2, 0. And we're given the graph. You can see that point 0 is here, the little bounce here. We already talked about what instantaneous rate of change is, and that would be the slope of the tangent. And we can just look at it from the graph that the slope of tangent in here is just the x-axis, and therefore the instantaneous rate of change should be 0. So that would be our estimate, and let's see if we're correct. So step 1, we have to write out a function. We know that there are 2 roots. There are actually 3 roots, but there are only 2 roots that are labeled. One that's 2, the other one that's 4. So here we have x minus 2 squared. It's squared because there's a parabola at x equals to 2. And there's x minus 4 here because one of the roots is 4. It's an even function, so there should be an extra x to have a positive degree. A is a possible number that compressed or expanded the graph, and we'll try to find out what A is. I say it's an even function because both ends of the graph went to the same direction, and that's they went to negative infinity of y. So in step 2, we try to find out what A is. We do that, and what we do next is we substitute 1 and 3 into the original equation. So when we figure all of that out, we'll get that A equals to negative 1. So we substitute that back into the original equation. We substitute A equals to negative 1 back into our original equation. And we will get f of x equals to negative x times x minus 2 squared times x minus 4. And the last step, we have to find the instantaneous rate of change with slope closest to 2, 0, and in this case, A equals to 2. Let's put that information in an equation that we're already familiar with. That's f of a plus h minus f of a divided by h. And from this, we can get the instantaneous rate of change. This is the instantaneous rate of change equation. We already know that A equals to 2. For h, let's just use a number that's really small and see what the instantaneous rate of change will be. So we choose 0.001, that's a pretty small number, and we have to plug it back into the original equation. Ignore the h's on this side. This should not be h, this should be instantaneous rate of change. So the instantaneous rate of change of f of 2.001 minus f of 2 divided by 0.001. You can see that the instantaneous rate of change is equal to 0.004, which is essentially 0. Therefore, the rate of change at 0 is approximately 0. So that's the end of this lecture. Thank you for watching. And